your conference.
Thank you, Lindsay. Good afternoon, everyone. Welcome to using Harmony for VRR calculation to comply to AER permits. VRR is Voidage Replacement Ratio. AER is Alberta Energy Regulator. As introduced, my name is James Ewart, and I'm a reservoir engineer working in the Technical Sales Division of IHS Harmony. I'd like to thank you all for attending this webinar as we discover together what's called by our consulting group, Harmony Decline's Best Kept Secret. This is based on a live presentation I gave a few months ago in Calgary. I'm aware that several attendees to this presentation are not from Alberta, but they're mandatory consistencies with whichever regulatory body you adhere to. Today, I'm talking about VRR in terms of general theory, forming a quick demonstration in how easily we can conduct this analysis in Harmony. This presentation does not address reservoir optimization, but I want to mention that Harmony's diagnostic plot can be used to compare changing GORs and WORs in our enhanced recovery system as material balance capabilities. Housekeeping slide here on how to ask questions during the presentation. If you hover your mouse over the drop-down menu at the top center of the WebEx presentation, select Chat, and then type the question in the box and send to submit a question for the Q&A period. A bit of background on me. I spent 6 years with the Yukon government in the area of oil and gas licensing and compliance enforcement. I understand the challenges companies have in documenting their compliance, but also communication of this compliance to a government body. I found that when industry was proactive and not reactive, it led to smoother and less complicated relationships between company and government, which I think we can all agree works out best for all those concerned. Our today include the Voidage Replacement Ratio calculation, the VRR. I'll walk through a surveillance example in Harmony. I'll discuss of the surveillance module, and conclusions and questions. Ratio is one measure of the effectiveness of an enhanced recovery or secondary recovery scheme. VRR can be calculated on a monthly and or cumulative production basis. The consultant group has noted an increase in activity by the AER in surveilling annually on all secondary recovery schemes in the province. And for those of you not aware of how our company is set up, we do have a consulting group, and they've been using the surveillance module for VRR permits for the AER quite a bit. And over the past year to 2 years, we've seen a huge influx on that, which is why we decided to do a webinar and a live presentation to bring more attention to the fact that we do have this functionality in Harmony. VRR has water and gas injected in reservoir volumes in the numerator, oil, free gas, and water produced in reservoir volumes in the denominator. Basically what this means is the stuff we're injecting divided by the stuff we're producing. The figures here convert the injected and produced volumes back to reservoir volumes. And a secondary recovery scheme is typically one that and maintains a VRR of 1. In order to calculate a VRR, you require accurate and representative pressure and PVT data. PVT can come from the AER, but the respective companies would have this information readily available as well. In terms of PVT data, we can rely on correlations, which Harmony provides. An AER approval will stipulate the VRR conditions. Some stipulations can include the operator must maintain a voidage replacement ratio of 1 basis of cumulative production and injection volumes following the commencement of production or injection, and target a voidage replacement ratio of 1 on a monthly basis. VRR conditions can include a minimum or maximum operating pressure, or VRR may stipulate a range for cumulative VRR. Expected to monitor the VRRs in all their secondary recovery schemes on a regular and ongoing basis. Harmony do for you? Compact surveillance module that enables you to calculate cumulative and monthly VRRs quickly and accurately. It also includes correlations that can be in the absence of PVT data. These questions require minimal inputs. The example we'll look at today contains 3 patterns. These have already been analyzed, so we'll be working on pattern number 1. We'll walk through what inputs are required, including reservoir properties and pattern allocation, generate a VRR for pattern number 1, and then generate a VRR for block number 1, which contains all 3 patterns. For example, we're going to use the minimum inputs necessary, but then static pressures to show functionality. So what I'm going to do now is bring over Harmony, which I already have open. And for those not familiar, this is the GIS screen, which is what we're presented with when we open Harmony. What here is I have 3 blocks. I have the block number 1, block number 2, and block 3 at the bottom. Down to the left, I have 2 and pattern 3, which have already been created. And concentrate on creating pattern number 1. To block number 1. And what I'm interested now in is which wells contained within pattern number 3. So pattern 3, select constituent wells. And I can see at the bottom here that these wells are those that are located within pattern number 3. I'm going to hit pattern number 2. Here, that's within pattern number 2. And you can see patterns here are located in block number 1 north. So now what I'm going to do is I'm going to create pattern number 1. So pattern to block 1 north, and I click, and pattern number 1 now exists. Now there are several ways we can add wells to pattern number 1. I can select them directly from the entity viewer, or I can drag and drop them from the GIS screen, which is what I'm going to do now. Wells here. I'm going to pattern number 1, and now populated pattern number 1. Notice wells here right in the middle, they were already part of pattern number 2 as well. And I have pattern number 1. So what I need to do now that I've created pattern number 1 is to set my pattern allocations. So pattern number 1, which to go to editors, allocation. Here, what your eyes probably jump to is that I have 2 red cells. The reason for red is for total allocation, the maximum I can have is 1, which means 100%. When I get a pattern, Harmony defaults to say that the producing wells and the injecting wells are 100% contained within your pattern. For wells that were contained in pattern number 2 and pattern number 1, we split it 50-50 down the middle. Pattern number 2 already has an allocation for those 2 wells at 50%. So I'm just going to update this under pattern number 1. Allocation is equal to 1, and Harmony's happy. The producing wells here, and click on to show the properties. What you'll note here is I have not populated any of the reservoir properties into this well. I have some default PVT data, such as gas gravity, and oil gravity. Those are all defaults, but I added any information into there. Well, information was input for that, and the information that I put in was initial and reservoir temperature. And I also have a gas gravity, which is not required, but you'll see what that is in a second. Notice that there's a number of required here. When we do a lot of different analyses in Harmony, RTA specifically, but for the VRR itself, they're not required. All the base minimum is our pressure and our reservoir temperature. And this is at the well level. So I've produced injectors here. When we pattern, we need properties at the pattern level. You can see what Harmony is it copied the initial pressure from my injector and placed it at the pattern level automatically. It on my reservoir temperature automatically and populated at the pattern level. If my default for gas gravity was 0.65 and injector was 0.8, And so what Harmony did was it averaged it out. And so what Harmony does by default when you create a pattern is it the lowest initial pressure of any of the subsequent wells under the pattern, average all the other information from all the wells. If you see with what Harmony's done, you can any time within the pattern number 1. And create a replacement ratio. What the plot looks like. The line here, which mostly is going to be 1. I'm going to here. And the dotted line is our instantaneous VRR, which in this case is our monthly VRR. The solid black line is our VRR. Pre-injection production. And sometimes, depending on what your permit stipulates, you include or exclude. Here, with pre-injection production included, the cumulative VRR is nowhere near 1. In this case, we were meant to exclude it. And projected came a little bit, and we're getting a lot closer to 1. Source, you'll see results to initial pressure and static pressure. You can have your source be constant. What I'm going to do now is add in some static pressure data to show that there is a difference between having it be constant or adding the static pressure data. If we were to think back to the formula that I showed earlier, the static pressure data is going to have different values for the different formation volume factors, which in turn changes what the total output from the VRR calculation is. So pressure data, I'm just going to launch one of the wells here. Static. The data I output from AccuMap. And so I'm just going to copy the dates into Harmony. I'll try it one more time. Do is paste in the static run depth pressures. You can see my units are a bit different. So anytime you're inputting anything into Harmony, it's always best to make sure you have the right units. And so I'm just going to click at the top here to toggle units. I'm going to I'm just back to PSI. So when we put in static pressure data, by default, we expect that we're going to go to see if we believe what we're seeing or if they're good values or values we don't want to include. And so if we want to use these values in our analysis, we need to check these boxes. If I'm all my data, I click here and select range. Static pressure data. I'm going to go back to my pattern number 1. I know the reservoir pressure was 5,000 psi. And between the two and see what the difference is. There's not much of a difference in this case between these two cases when static pressure was added. But in different cases, by having that static pressure data, it could be a lot different than having constant pressure and therefore constant formation volume factors. The thing that Harmony can do for us in the VRR plot is we can add different plots to overlay on top of the VRR plot. Several times is to overlay the GOR and DOR on the same plot. One is we create a pattern from the GIS panel. We made properties for what we wanted for pattern number 1. We created a VRR, and then we static pressure data and choose whether we wanted to keep it constant or use the static pressures. And we create a custom plot the VRR and other plots that we wanted on the same plot. Now what we can do is actually go up to the block level. So I'm going to left click here and block. Valence module, voidage replacement ratio, VRR is time. And is the aggregate of all patterns, patterns 1, 2, and 3. And as we I'm going to actually exclude pre-injection production again. Here that we're actually appears that we're over-injecting on a cumulative basis. What we can do is dig a bit further. If you had a block with several patterns, what you do is then overlay each onto the same plot. And as over each of these patterns, how it bolds in the plot itself. Let's take a look at these a little closer. Pattern 1 we're familiar with, close to a VRR, cumulative VRR of 1. Number 2 is we're really injecting. Let's take a look at pattern number 3. We're overinjecting, but by no means as much as pattern number 2. Using this VRR plot, looking at the aggregate of all of them and looking at every single pattern, it can help give you information into what might be going on in certain patterns. Are you over-injecting, or was the reservoir characterization done wrong? Should we add different produce to this to this pattern? Are there too many injectors that aren't be a part of this pattern? Are we losing injection fluid somewhere? It can help highlight where you may have issues. Module as it is today is we're limited to secondary recovery schemes. We just did a very quick example. It's quite hard to make the example longer because it is very easy to do in Harmony. But our conclusions are that the Harmony surveillance could be our best kept secret. It's severely underused, and when we get work in through our consulting stream, we find that they use it quite often, and so we'd like to give this power out to the hands of our clients. It's capable and easy to use, and people use it, and when clients use it, we get feedback. Feedback is always welcome for us to make future improvements. I'd like to open it up to questions.
And as a reminder, there is a question window and a question box where you can type your questions in. James, we do have one that was entered, and it's the AER likes to have the PVT data that was used to generate the formation volume factors for the VRR calculation submitted as well. Can you get this data out of Harmony?
So that's a really good question because I'm not sure how permitting is done around the world, but what the PVT data is going to give you is a scope of what you use to actually generate your formation volume factors, which then led to your calculation of VRR. And so what we can do, properties, actually maybe I'll do it for up here at the pattern level. Yes, we can. So what we can do is we can generate, these were from correlations from just entering our initial pressure and reservoir temperature. And we can right-click this, copy plot, and can actually paste it into Excel. Now, some people will have custom data. We also allow for creating a custom table. The values you put in, or the correlation data, or something else, which it goes a little bit beyond the scope of this presentation. What you can do is import your custom PVT data and then the correlations to your custom data. We see that quite a bit in RTA analysis, and we can also do it for VRR as well.
Fantastic. We'll leave the line open here for another 10 seconds to see if there are any other outstanding questions. Okay. We've answered questions that have been brought to our attention today. But James also have some contact information you can share if questions do come up after.
Absolutely. Let me just bring this back up. Always available through our technical support line. You can always send us an email. The harmonysupport@ihs.com is generally the best way to get in touch with us. And I will just go back to the first slide where I believe my personal email is. So thank you for tuning in. But it is powerful. I'd encourage you to think about the work that you might be interested in doing and how this is easier to do than a spreadsheet, particularly with changing pattern allocations with time and the access to correlations being the two major reasons it is better. So I'd like to thank everybody. Thank you.
Today's conference call, you now disconnect.